Good morning, everyone. Today is going to open your quiz and your assignment after we finish with the lecture. So you have homework, quiz, and assignment, and as usual, 1 week is due next week. So take a look on Canvas later. The last topic for LISP. We review how to call functions, instructions, primitive data types, how to create our own functions. The last thing is, let's put everything together. And the best way to put everything together is, well, data structures. What can we do to handle data with the elements that we described before? What can we do to handle data if we do not have data types? We haven't talked about arrays or classes or objects or something similar. So data structures. For data structures, the idea is going to be the same that we have before. Everything is inside of parentheses. And for instance, you want an array with numbers. That one is your array of numbers. Wait, you want an array of strings. Replace the numbers with the strings. You want an array of complex numbers, an array of whatever. You just put the data inside of parentheses. That's it. Now, we have a small problem. If we only do this by default, according with the things that you already know, this, the first element, LISP is going to think that that first element, like the one here, is an instruction. Because by default, we put something inside of parentheses, and this first element is the instruction, and the others are the parameters. By default, when we do something like this, for LISP, this is a function, and a function has a name and parameters. The only thing that we need to do is to tell LISP, this is not a function. This is only data. Forget about the first element being the name of the instruction, the name of the operation. The first element, used as the other, is data. Data in a group, an array. We can do that in two ways. Number one, the easy one. You put an apostrophe at the beginning of everything. That small apostrophe is telling LISP, you know what? Don't care. The one is data. The one is not an instruction. In this example here, you notice the apostrophe, the parentheses, open and close. And what we have there is an array polymorphic. It's like an array of objects. It's an array that have the first element, a word, hello, a string. The second element, another word, a string. And then 3 integers. An array, a collection of data, 5 elements, 2 are strings, 3 are numbers. There are no data types. We do not need to worry about one array for a string and another array for integers, or using a polymorphic class with nothing. It's just an array with 5 elements. Well, a small thing. I am talking about this like arrays just because it's a collection of elements. To be more specific, these arrays do not have a predefined size. These arrays can increase or decrease dynamically, and I am going to show you the instructions for doing that. What is the name for an array that can increase or decrease the size? You know that, right? A linked list. Here, we're going to remove the linked and use list. These examples here are lists. And Also, functions were lists, remember? In Lisp, everything is a list. Parentheses with something inside, the first element in the instruction, that particular kind of list is a function. Parentheses, something inside with the quote at the beginning, that particular list is data. Same syntaxes, with or without the quote, the single quotation mark. Actions, functions, or data. Now, there is one problem, and here the second thing. It's very hard to read this quote. Even if you're looking at my slide, that one in red is like there is something there, or is just something in the paper. The same thing happens when you're programming. Is something there or something on the screen? Second option, you can put the quote, work, or you can put your data and enclose your data in parentheses and use as a name for a function this is instead of the apostrophe. So option number one, the apostrophe outside of the parentheses, done. Option number two, if you think that the apostrophe is hard to read or you want your program to be easy to read for others, put your data inside of the function quote. The function quote has only one parameter. That parameter is your list, the list that you want to be data. That's it. So in my example number one is exactly the same that my example number two. Option one, option two. Now, quote or the apostrophe, both return data, return something to the interpreter. You're going to notice that the interpreter, after you create a list with data, is going to print something. What? The data. Exactly the data that you're creating, your array with your values, is going to be printed. Notice, including the parentheses. Everything that we did before, the results were without parentheses. Primitive data, or a message, or a numeric value. Here, what the interpreter is telling you is, okay, I got it. This is an array, a dynamic array, a list. This is your data all together. Same result here and here. And well, that is easy. Now, these are linked lists. These are arrays. The question that for sure you have right now is, well, that work with one-dimensional arrays. What happens if I want a two-dimensional array? What happens if instead of an array like this with these numbers, I want a table, 2 rows, 2 columns? Well, for the first one, parentheses, 1, 2, 3, 4, parentheses, and the post. That is data. For the second one, do you remember that two-dimensional arrays are really arrays of arrays, right? At this point, you remember all the things that we review with Java, with C++, and you remember that, well, basically this guy is really one array with the 1 and the 2, another array with the 3 and the 4, and then there is an array here that have these 2 elements connecting them, pointers, and the full array is really the name of all that construction. You know that this is the representation in the memory. You know that this is what happened in the other languages. Because of that, hopefully makes sense. If I tell you that in order to do this in Lisp, what I need is a list, and that list is going to have 2 elements, and those elements are going to be Did you notice the difference? In the first one, I have an array of four elements. In the second one, I have an array of two elements. And those elements are arrays, parentheses. And inside of those 2 arrays, what I have is 2 values in each of them. In total, 4, the table that I am showing you. Okay, but what if I have a table and the first one is 1, 2, 3, but the second line only have 1 element? These are null, nothing there. And then the next one have 2 elements. This is null, nothing there. I am sure that you can transform this table to a representation with pointers. You know what happens here. You know that you need to create a new or a malloc for the array of 3, and then for each of the elements, create the mallocs for the particular arrays in 1D. This one, in LISP, well, I have my parentheses. I am going to have 3 elements. The first element with the numbers. The second one have only 1 number. And the other one have 2 numbers. I do not need to make all the elements size 3. I do not need to create a table. Only 1 element. Only 1 element. What happened with the nulls here and all this low-level thing with pointers and so on? You don't care. You only care about your data. You want 3 elements, they are arrays. One have 3 elements inside, the other only 1, the other 2. That's it. Going back to the examples. That one. What is that one? How many elements do I have in this array? 4. No, very good question in the chat. This is like the comments. For all of this, the only thing that I need to do is 1 quote here at the beginning. That's it. Once I put the quote at the beginning, this is not an instruction, this is not an instruction, this is not an instruction. This quote at the beginning is going to cover the full line. So you do not need to put the quotes for every single time. And think about it, that is good. We already have a lot with so many parentheses. Just imagine quotes in every place. So quote at the beginning, done. Similar with my example here, quote at the beginning, done. You do not need a quote for the others. Is here, everything is going to be data. Now, the other one here. The 2 examples that I showed you is like, okay, bidimensional arrays, table. 1-dimensional arrays, good. Everything is an array inside of an array. This one here, I agree with the idea, 4 elements. And if I think about 4 elements, hopefully you are going to agree with me. It's like, well, you have element 1, a string, and that is the first thing in your array. The second element, you have another string like this. And the next one is something crazy with parentheses. But the last one is another string. So yeah, I have an array of 4 elements. The first one, the second one, and the last one, strings, they are easy. Yeah, the question mark is another character, is part of the string, no problem. The problem is here. I have 2 strings, but I do not have 2 strings like 6 elements in a line. I put parentheses. And if I put parentheses, is because this going is one element, and this on is a second element, right? This one here is kind of another array, like another row in a 2D array. If I do this in Lisp, what I am going to have is an array in which I have string, this guy, a pointer to a string, a pointer to a string. And that pointer to a string is 2 strings going on, and then another string. I have an array, a linked list with string, pointer to string, string. And the pointer to string is pointing to an array with string. Did you notice how easy it is to mix any data type, even pointers? Now, looks good. I am sure you're thinking like, well, this is working for arrays. Looks like they are dynamic arrays and therefore linked list. What happened with other data structures? Because you have data structures that are linear, arrays and linked lists and all the combinations that you can create there, stack, queues, and so on. But there are other data structures. There are things like that, a tree. What can we do to represent a tree in Lisp? Well, if you remember a tree in your data structure classes, in order to represent a tree, you use a class node. And the class node have 3 elements: the value, the data, and the pointers to other nodes, right? A node with 3 elements: the data and the pointers. Well, this guy could be something like data, the value is B, and then is a tree, is binary. It could be the value, and then I have 2 pointers. I have 2 other elements connected. Well, and what happens if I have here child? Well, the problem is with this guy, right? This is the guy that have the child. So that guy is C, and the childs are 1 and 2. The only thing that I do here is, well, this should be here. Just put that C and parentheses and the others beside, and that is your tree. And you can be thinking like, well, but this A is different. This A is use a value. Yeah, because we do not have childs. We do not have nothing here. In fact, What we have in a tree is a list that have pointers. Think about this B and 2 pointers, pointers to other nodes. Think about this C as the value and 2 pointers, pointers to other nodes. Think about this A like only the value, and these are nil and nil. If they are nil in LISP, I do not need to include them, only the value. The value, parentheses, for the pointers. The first one pointing to only a value. The second one, open parentheses, a value, open parentheses, its own pointers, closing parentheses, closing parentheses, closing parentheses. With this idea of apostrophe and with putting together parentheses, you can represent a tree. And if you can represent a tree, you can represent a graph. And you already are representing arrays and linked lists. All the data structures in LISP are represented in this way. The only syntactic elements that you need to know are the parentheses and now the apostrophe or the function quote. That's it. And we're going to do more examples, don't worry. So moving forward, this is also valid. This is correct. And question for you guys, what is this? Can you agree with me that that one is an array with one element? Or that that one is a linked list with only one element? Is the simplest list that you can create. There is no parentheses. 2 ideas. If you give me this, parentheses, quote, the name of a variable, what you have is this array with this value inside. It's an array, one element. Another option, parentheses, quote, parentheses, x, parentheses, parentheses. If you use parentheses here, what you have is one element that is a pointer to an array with one element. It is clear the difference. It is valid. You can put quote, only one element, you have the element. You are telling me that my symbol or that X is not an instruction, is a value, is alone. Open parentheses, good. You are telling me that that one is going to be a list. That list have, in this example, one element. Every single time that you work with Lisp, you're working with arrays, you have a pointer to the element. Both are valid. The only thing is, remember, parentheses, 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 those are lists. Here, good. You have this name and you want to let me know that that is the name of a variable, that that is not an action, that that is not something that I need to execute. It is fine. The result that you're going to get is the name of the variable, just like this. Yeah, be careful. This, the interpreter, always, always, always is going to print things in uppercase. Remember, this is not case sensitive. However, usually what happens is you write your instructions in lowercase or in a combination of lowercase, uppercase, whatever, and the interpreter, in order to highlight the result, is usually going to put everything in uppercases. Everything, if you remember when we define a function, the name of the function is printed in uppercase. Here, all the data is transformed in uppercase. Always, you're going to have the result, the thing that I am writing in blue color in my slides, they are going to be in uppercase. Not for a particular reason, but because the interpreter wants to be sure that you read the result. Uppercase. That is correct. Now, here, I do not have parentheses because this, my symbol, is not a list. It's not an array. It's only one element. It's a variable, one single thing. And is the name of the variable. What I am printing here, when I put the quote and the name of a variable, what I receive as a result is the name of the variable. This, my symbol, is the name. And inside, I have a value. That is the reason because I do not have quotation marks. If you remember, in the example, when we print something or when we're working with strings, the result here have quotation marks. Quotation marks, what you have is a value, is a string. Parentheses, what you have, like here and here, is an array, a group of elements. But when you do not have quotation, when you do not have parentheses, what you have is the name of a variable. It's not a value, it's a variable name. Therefore, this one, I can do something like print my symbol. And what I'm going to have on the screen is the value inside of that variable. I don't know if it's a number, a 5 or something. I am not showing you here the declaration of that variable. The variable do not exist. So I need to create a variable, then I can do something like this, and then I can do something like this. Is the name of the variable. Different if I do print quotation marks, my symbol, what I get is that a string, a value, no quotation, the name of the variable, no parentheses, only one value, parentheses, several values, or at least an array that can be increased or decreased. The main difference is in the instructions that I am going to show you later, I cannot add more elements here because it's not an array. However, if I put parentheses, I can use that one to add more elements. Just like when you call the method add in a linked list, I can use that name, add more elements, and therefore have more values inside of that. Here, without the parentheses, what I am telling, this is a variable, that's it. Yeah, when you use the quotation marks, what you're going to have here printed is the same cases that you use, upper or lowercase, because it's your value. For the name of the variable, uppercase. Now, what happened with something like this? If you remember, when I want to do an operation, like I want to do the addition of some numbers like this, this one there is an instruction. That one there, if you run this, is going to give you as a result, and I am going to use here a comment, something like 2 plus the result of 3 times 4, right? So you run this, and you are going to have on screen the result. What happened if you put a quote here? Everything changed, right? If I put a quote there, what I have is something different. Now I do not have instructions. This is not an instruction, the plus, anymore. This is not an instruction, the multiplication anymore. All of them are data. If you put the quotation mark here, what you are telling to the interpreter is, this is data. This is an array, some kind of list. You do not need to execute anything. And what the computer is going to do is, okay, what you want now is an array in which the first element is the plus as a character, the character plus. The second element is a number, the 2. The next element is another list. So I am going to follow this idea of pointers. It's a pointer to another list. And that's it. I have here 3 elements. 1, 2, 3. Well, the second one is a list. It's a list with 1 element, 2 elements, 3 elements. Only data in a tree. Wait, what happened if instead of the 2, this one here, I want to do the addition, but I do not want to use only a 2. I want to use another multiplication, and it's going to be the multiplication of 1 and 2. Okay, you change one value for a list. Good. Then what we're going to do is to change in the memory one value. It was a value, right? It was a 2. But we decide to change that value for a list. It's no longer a value. Now it's a pointer. It's a pointer to another list, to a list with 1 element, 2 elements, 3 elements. Looks like a tree, right? The same representation that we used in the example before for trees. Parentheses inside of parentheses. With that, we create trees. Every single time that you use a new set of parentheses, what you have is like a pointer pointing to another list of values. And as you can imagine, this can continue. You know what? I want to do the multiplication of 3, but not times 4. Instead, the multiplication of 3 with the addition of 4 and 1. Okay, I have replaced this 4 that was a value for a list, which means that now this guy is not going to be a value, it's going to be a pointer. It's going to be a pointer to another list, and that list have the plus, the 4, and the 1. And what is happening is my tree is growing every single time that I put parentheses inside of parentheses. And only one quote. With that, everything is data. Doesn't matter that I am using here operations. The computer is going to understand that those are not operators. I do not want to use the operators. I just want to create a tree. And here I put the worst case scenario where those are operators, but you can change this. And my first element here is not the plus. My first element there, I want to be a number. My first element here is not a multiplication, but I want to be letters. This one is going to change for a number. And the other one is going to change for a letter. I can do whatever I want. They are values. The computer is going to use the data type that fit the values. That's it. Moving forward, this is hopefully looking good. So any collection of data, I can represent that only with parentheses and the quotes. Good. Now, what can I do with the data? There are some instructions in Lisp that works with lists. There are instructions that are equivalent to the add, remove, get, and so on that you have commonly in any data structure. In any data structure, you want to add more elements, you want to remove elements, you want to get all the elements, get a particular element. Common operations for data structures. Here, the common operations for list in Lisp. And we cannot cover everything. We cannot cover all the API, but we can cover the most important, the classical ones. Let's see. Classical instructions that we are going to use with list. Number one, first. It's going to give you the first element of the list. You use first, you give me a list, and then the instruction give you, this is the first element of the list. Think about this like get 0. You have a data structure, you call the method get, and you use the index 0, give you the first element, right? First. Rest. First, give you the first element. Rest, give you all the others. Everything that is not the first. I am going to show you examples. But first, the first, rest, everything, but not the first. Append, concatenation of list. Put two lists together. Append. Const, remove one element. Remove the method, const. Now, a big parenthesis. The current name for the function is first, rest, append, const. However, for these two, first and rest, they have those names now, but the original name, if you remember, the language is from the 70s. The original name for those functions was car and CDR. Car, content of the address. CDR, content of the decrement register. Names for the 70s. CDR is rest, car is first. And you can use both usually in any interpreter. The interpreter still understands car, and what do is getting you the first element. The interpreter still understands CDR, and it's the same that rest. Both names, first and rest, I think are easy to remember. Car and CDR, well, you can get used to them. Okay, examples. First, car. Let's work with this. Number one, the first thing that I need to do is, if I am going to use those methods, a list. I need a list. And I need a list. And for instance, I can be working with parentheses, car, and apostrophe 1, 2, 3. What is going to be the result of this instruction? Car, apostrophe 1, 2, 3. Did you notice that the quote is for the second parenthesis? The quote is here. That one is the list. Car is a function. There is no quote here. car is going to be executed. What I want to do is execute car and use as a parameter this array, this list. What is going to be the result? Car, apostrophe, parentheses, 1, 2, 3. Remember, car, first. First what? The first element of what? The list that I am giving you as a parameter. What is the first element in a list? 1, 2, 3? 1. That is going to be the result. You can use the instruction, and you can use quote here, and you can put, and this is the parameter. And this quote is replacing the apostrophe. And if I ask for the result here, the result is 1, the first element of my list, right? Now, all this is kind of good, but it's kind of long to be writing every single time all the values in the list. It could be good to create a variable, setF. Remember, setF is the equal. SetF, and I can use a name for the variable, and then I can have a value name. What I am doing there is to create a variable, and that variable is a list, and that variable is the name for all of that. It's like when you create an array in Java, x equal new data type and the square brackets. This is the real array, the values. It can be a variable that have all of that inside. Then you can do char, and instead of the values, then give me the first element. The first element where? In the variable x. Obviously, x should be a linked list. Is a linked list. The result of this char x is going to be 1. Think about it. Having variables could make things easier, because now I can ask for the rest of x, and I can put here use x instead of, again, all the values. My result, 2, 1, 3. Remember, first give you the first element, you like that. Rest give you a list with all the other elements. So the first element, 1, a list with all the other elements, a list, parentheses, with the others, 2 and 3. Going back to the example. Step number 1, setF, the equal, the name that I am going to use for my list, I can use upper cases and lower cases, right? The value, notice the quote. I am using the apostrophe. All of this is going to be the list. What do I have here? 3 elements. And those 3 elements have 2 of them lists. You can think about, I have the first element that is really a pointer to 2 elements. The second element is a letter, and the third element is another pointer because of the parentheses, even though what I have there is only 1 letter. You can do exactly the same, removing these parentheses here. Yeah, but if you remove those parentheses there, the interpreter is going to put this D here instead of the pointer that I am showing you. That is the difference. You have a pointer to an array of 1 instead of removing the pointer and use that space for the value. The interpreter is going to reply. It's going to reply with the values that you provide. This is the return of the apostrophe. And remember, the setf return the value of the variable. So that is the value for the variable. Every time that you use setf, your return is the value that you put inside of the variable, the value that is after the equal. Good. So here we can start playing with the instructions that I showed you before. As in my example, car, I am asking for first. Now, the good news, I can use those functions recursively. We talked about recursion before. For instance, just for playing, I can use car and pass as a parameter to car another call to car. Remember, it's like first of the first. And this is my variable. Let's think about it. Which is the result of this one? And I need to do first the one that is inside of the parentheses, right? That is the precedence. We start with the parentheses inside. What is the result of the first element of the list, my list? And I am sure that you're going to agree that, well, according with this, the first element here is that one. The first element, the result of this, is parentheses A and B. That is the first element, just like that. This is the first thing that we have before a white space. And this is going to be the result. And now I am asking for the first of those ones. And you're going to agree with me that the first here is just A, and that is the final result of this instruction. Obviously, this works because the first element is a list. So you get the first is a list, you can use first again. If the list have as a first element use a letter, this is going to give you an error because you cannot get the first of use a variable, right? But if you have lists, this continue working. In the second example, similar idea, but now I have the rest of whatever result for the first. This, the first of my list, is going to be again, in this example, A and B. That is the first one. And now I am asking for the rest. The rest, the result is all the elements, not the first. All the elements, not the first, only B, because the first was A. And always, 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 rest, CDR, is going to return a list. And that is the reason of the parentheses. Always, rest, return a list with all the elements except the first one. First is going to return the first element. Doesn't matter if that first element is a single variable or a list, like in this case. The first element, whatever it is going to be returned. But rest always return a list. So even in this case in which the rest is only one element and is a single element, rest is going to put that one inside of a list as a rule. Good. Now, the last one, I can do also the opposite. I can put rest here and then call for the first. Any combination is valid. Solving this one, I can tell you that the result is C. Can we figure out why? And it's like, well, I am calling CDR. According with the rule, CDR always return a list. So this CDR always is going to return something inside of parentheses. And it's going to return all the elements except the first. The first one we know is this AB. So all the elements except the first one is C and D. And notice that I am using the parentheses of the div because it's all the elements except the first one. So all of this inside of a list. That is what the function do. Good. And then I am calling first. And when I call first, I get the first element. The first element used like it appear in the list. It's a C without parentheses. It's going to be a C without parentheses. If I call first in the full list, it's going to be A and B inside of parentheses. It's not going to change anything. Only rest, put everything in parentheses. So first and last, a combination. Hopefully easy. You can practice and review this in your virtual machine. Check for the results, play with different combinations, maybe put here numbers instead of letters or strings instead of letters. See what happens. More examples. We can go crazy with the list. For instance, set f equal my list 2, quotation marks. How many elements in that list? And yes, you can use parentheses empty that represent like nil or null. You want the pointer, but you still do not know what is going to be pointing. It's an element. How many elements in my list 2 if I ask for the size of that? Yeah, answering the question in the chat, if you use let x and then you put a value that is a list, also work. Now, only remember, let is going to create a variable that is local. So the list is going to be the value for a local variable, but yeah, it can work. So how many elements here? It's like, this is one element. And then I have here parentheses. That is the opening for the second element. Is closing there. So all of this is the second element. Another parenthesis there. Looks like it's going to close until the end, because these two are here together, these two are here together, these two are here together, this is connected with this one is closing the other. Here, these two are together, these two are together, this one is closing mine, this one is another one, and this close the full list. So 1, 2, 3, an empty one. Okay, whatever is the value for my list, a lot of empty elements, fine. I can play with first and rest, my list, and let ask car, just like before, the first and the first. This is the case in which I mentioned before. First of the list is A. This is the first. And if I ask for the first of that, I get an error. I cannot ask for the first if the parameter, this one, is not a list. So that is the reason. Well, similar, if I ask for the last of that first, if I ask for the last of A, I cannot ask for that because that value is a variable, not a list. I get an error. But what I can do is ask for the rest of the list. The rest, all the elements except A. All the elements except A. Well, all the elements except A. what you are going to get is, here are some missing. When you print the result, all these parentheses empty, they are going to be shown as nils. They are the same. Empty parentheses represent this idea of the pointer that is not pointing to any data. The representation that you're going to get for the interpreter is nil. Is I have your array with your value b, and this that should be a pointer is not pointing to any place. I do not have values here, so it's null, nil in this case. And then the other, well, the other is pointing to a list, and this list have the C, the first element, but I have other two that are not pointing to anything, that are these parentheses here, and we need to continue with the other values. Parentheses empty, nil. This is the rest of the list. Well, partially. I can use first, or I can call first for the rest of the list. And this is the first element of the rest of the list. Remember, the rest, everything but not A. This is the first element of that rest of the list. So this could work. First and rest. A lot of questions in your exam, guys, like this. We're going to give you lists. We're going to play with first and rest, and we expect you to be able to calculate these blue results. Understand what happened, what is returned, and what is the next operation to happen. Practice with this is going to be in your exam. It's going to be also in the quiz that you're going to solve later. It's going to be the quiz that is open today. So moving forward, we have these operations first and last, good. But the next thing that we usually do with a data structure is iterate the data structure. What if I have a data structure, an array, a list, a tree? I want to print the elements. That is common operation. Now, common operation, and in other programming languages, here you could use a for loop. So a loop from the basic of the language. But also in several of the programming languages that you review, there are particular instructions, a particular loop that apply to data structures. For instance, instead of a for loop, you have for each, right? It's the same idea of the for, but is for or applied to iterate in data. The equivalent for that in Lisp is this do list. Do list instead of do times. Do list because I am going to iterate a list. A structure, very easy. Number one, open parentheses, do list. Second, the parameters. If you remember, for do times, you have that instruction, you open parentheses, and the first thing there is the variable that control the loop. We reviewed this x as a variable. And then the second one was how many times I want the loop to run. That was do times. Do times, variable x, 5 times. And you are going to have the variable x with the values increasing. For the do list, we also need a variable. The variable that is going to have one by one the elements on the list. And then we need the list. Use like do list, my variable x, and here, the list that I am going to iterate. It could be the list like this, apostrophe, parentheses, and the values, or it can be like before, the name of a variable that we can create with setf. Any option work, but it should be a list. And optional for the do times, remember that you have a third parameter that could be the return value for the do times. If you put something here, that is the return value. Similar here, optional, the return value. Optional, so if I do not put here anything, use close. That is good enough, but this do list is going to return nil. So you're going to have in your interpreter at the end this nil printed because it's the return value. You didn't put a return value, return nil, just like the loop, the do time. Anyway, the important thing here is I have a loop. The loop have a variable x, and that variable is the one that is going to have the values of the list, and therefore I can put inside of the loop instructions, and those instructions can work with the variable x, like printing the variable x. And as you can imagine, I am going to print the values inside of my list. And yes, they are going to appear in uppercase. Don't worry, no big problem. The list, the values, print the values. Done. Do list, your data structure. Now, I am going to ask you for that in just a minute. Yeah, append, don't worry. Answer into the chat. This is clear. Like, well, yeah, I have a list, it's going to iterate, it's going to give me the elements, printed. Printing is easy. I can do more interesting things with a list. Let's see. Now that we have all these instructions, we can put things together. And can we agree that what I have here is the definition of a function? Is the first part. That function is going to do things, but that function is going to be able to be called as this. The call and the definition. The call of the function. I am going to be able to call, open parentheses, my reverse. My reverse is the name of the function that I am creating. My reverse, the calling, definition of a function, my reverse. How many parameters that function is going to have? I hope that you agree with me. This function, my reverse, receive one parameter, only one. And that parameter is a list. I am sending to a function a list. I am sending to a function a pointer to an array. I don't care about pointers. I didn't need to think about pointers. I didn't need to think about passing values or passing references. I am just creating a function, and that function needs to work with a list of data. I send the list of data. Parameters. How many parameters? Only one. If I am sending one, I am going to receive one. Now, I need to be clear here. The name of the parameter can be whatever you want. I am using these orange letters list just to make easy to read that one is the list. But the name of the parameter can be cat, dog, X, Y, Z, whatever you want. It's just the name. There is no data type. I use their list, but that doesn't mean that it's the data type for the parameter or something crazy like that. It's the name of the variable that is going to receive what I am sending, whatever it is. Okay, so it's a function, and I have this variable. The variable is all this. So inside, answering the question before, I am going to use let. Now you know I have let. That means that I am going to use local variables in this function. Yeah, I am going to use local variables. Local variables. How many local variables? One. The name of the variable, new list. The value for that new variable, there is no value. There is no value. Remember, here is let, is parentheses inside your variables, whatever you need. Value, variable, variable, value. Here, let, parentheses, parentheses, variable, only the name. There is no value there. If you do not put the value, nil. Always, if something is missing, the return thing, the value, nil. I am creating something like new list equal nil, local, because I am using the let. Okay, I have the variable, is empty. Great. Next, instructions inside of let can use the local variable. Therefore, do list a variable x, the one that is going to be using the loop. Initial list is going to work with the list that I receive as a parameter. Okay, so I have the list that I receive as a parameter, and I have another one empty. Good. Inside of the loop, I have this setf. Setf, if you remember, like the equal, like the method set. What is happening here? Well, there is setf, new list. That is like new list equal to something, right? New list is the first parameter, and the second parameter is the value. The first parameter is the name of the variable. The second one is what is going to be here. What is going to be there? The result of this. Do you remember const? What is going to be doing const? Const x new list. What was const? I do not know what is going to do const, but is something related with this one, that is one element in the list, and something related with the new list. Const, an item, and a list. Yeah, it's true. I have the X and I have the list. And return a new list with the element at the front. Oh, it's going to add first. Okay, so going back here, it's going to take an element. It's going to take a list, and it's going to return a list with the element at the beginning. Well, the list was empty, and the element is the first element of the list. At the beginning, it's going to be the only element. This instruction is going to return a new list, and what I am doing is to store that new list here. Yeah, it's something like doing y plus x. The x is in both sizes. I am using the old value that something is going to happen, and one result is going to be created, and that result, I am storing the result in the same variable that I am using there. So the next time that this loop runs, something else is going to be added here, and something else, and something else, and something else. And always, 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 I am using the same variable to store the result. At the end, what is happening there? Why I have this new list, the name of the list, without parentheses, without anything before closing the parentheses of let? Why do you put the name of something, a variable, at the end of let without parentheses? Correct. I am going to return. What are you going to return? But the list in which I was adding elements. And I am going to return that the let is the last instruction. In fact, it's the only instruction inside of my definition of function. So that is going to be the return of the full function. Obviously, when I define the function, I write all of this, enter. The interpreter is going to give me in uppercase the name of the function to let me know that now the interpreter understands that I have a new function. Then when I call my function and when I call with this parameter, I am going to get this result. Again, the letters in uppercase, don't worry, it's because the result. But what happened here? What happened is that you send this list, A, B, C, D, and so on. And then you have an empty list. And in the empty list, you add the A, the first one, the first time that you run this one. And then the second time in the loop, X was B. And this instruction comes at first. So the instruction comes at the B at the beginning of your other list. And then you have another loop. Now you have the C. And you run this instruction. That instruction add at the beginning. So you add the C at the beginning and so on until the last element in the loop was the G. So your function is doing the reverse of the list. It's reading a list in a loop, creating another list. The other list is empty at the beginning, and you are inserting the elements of the first list in the second one. But because you are using add first, well, every single element is going to be added at the beginning. So you reverse the list. A definition of a function with list, with data structures, with loops, working. And hopefully this is clear. Something else to practice. More. I am going to give you this for you. I am running out of time, but I want you to review these examples. More definition of functions with things that we already reviewed. Let, do, setf, different results, different calls. Use your interpreters. Moreover, more examples. What is happening here? A definition of a function that is recursive. Even P, remember the P, predicate. Another recursive call, 1 plus, the 0 without parentheses. What is happening there? Another one, 2 parameters, 0p as a function, get, recursive. These look like your functions for trees. When you work with trees, your functions were recursive, remember? Usually trees, recursion, they work together very well. Review those examples. Any question, please let us know. But I think now you have the elements to understand everything that is happening in all of this. Moreover, I am giving you in the slides some problems. Problems, not for now, not for you to submit or something, problems that maybe you can use when you start studying for the final exam. The final exam is coming, LISP is included. These exercises is something that you can do as a study guide for the final. Questions? More questions? and extra questions, you can review, you can work on this. And again, any question, send us an email, ask for office hours, but practice with this. If you are able to solve these problems, you are ready for the final exam with the topic of LISP. Good? Okay, guys, I am going to stop here. See you next week. Thank you.